All right, everybody. Today we're going to be going over the exercise portion of your atomic structure POGL. So go ahead and get that out. All right. First, it says to complete the following table. So first off, we know we have phosphorus, and we know it's an isotope with a 31 mass. So this mass number right here is going to be 31. How do we know that? Well, we got that from our image right here. This 31 implies that our mass number will be, in fact, 31. And the number of electrons. Well, this has to do with the charge. Seeing as there's no charge there, that means that our charge is 0, which means we have the same number of electrons as we do protons, which means we will have the same as the atomic number, which will be 15. All right, it's not in order, but you get the gist. Our atomic number, we do not have any information about the atomic number given to us, which means we have to look on the periodic table for the atomic number of oxygen, and that number is 8. Our mass number is from our diagram here, and that's going to be 18, and the number of electrons is 8. All right, next row. Well, we don't have much information other than the fact that we know that we have an overall charge, an atomic number of 19. Well, if I looky here on the periodic table, black and white. Here we go. If I look here on the periodic table, I wish this would go away, but it's okay. The element with the atomic number 19 is potassium. So that means I'm going to have a K here. The other number on the other side is going to be the mass number, which we're told is 39. And we got to figure out what the charge is going to be. Well, that's going to be the number of protons, which is the same as the atomic number, which is 19, minus the number of electrons, which is 18. And that gives us an overall charge of a positive 1. So I have a +1 charge. Normally we don't write the 1, so really it's just a plus. All right, now we have nickel. We're looking for the atomic number. We can use our handy-dandy periodic table to find the atomic number of nickel. And nickel is right there. Our atomic number is going to be 28. We have a mass number of 58, and we need to find the number of electrons. Overall, we have a charge of +2, which means my protons, which is the atomic number, 28, minus some number gives me a +2. Well, 28 minus 26 gives me an overall charge of +2. Next up on our list, we have number 2. What is the mass in grams of 1H1 atom? We need the mass. We have 1H atom. All right, well, let's go look and see if we have some more information about this 1H. Well, we know right here that 1 AMU is going to equal 1 AMU equals 1.6606 times 10 to the negative 24th. That's gross. Grams. All right. And we know that the mass of 1H is 1.0078 AMU. Well, we can put that into a T table. Our given would be 1.0078 AMU. And our need is grams, which we're going to use this conversion factor to get there. So we know that AMUs are up top, which means AMU has to be in the basement. And that gives us an opportunity to have 1.6606 times 10 to the negative 24th grams up top. Now we'll do some math here. Multiply across the top, divide by the bottom, and that will give you your answer for number 2. Okay, so now what we're going to do is the same concept for 12C. So we'll go up here and find its mass. 12C is right there, and it's exactly 12 AMU, which means we'll go here and we have 12 AMU for our given. And here's our bar again. We'll use the same conversion factors, having 1 AMU in the basement, and on top we're going to have our 1.6606 times 10 to the negative 24 grams. We'll do the same jive turkey dance, multiply across the top, divide by the bottom, and that will give you your full answer for number 2. Number 3 says, what would happen if we had 4.35, so we have 4.35 times 10 to the 6 atoms of 12 carbon. Well, we have this many atoms and we need to somehow get to grams. Well, the only information we have about atoms is these are our images of an atom, okay? So that means that for every one atom, we have 12 atomic mass units, or AMUs. Next door, we know that one atomic mass unit weighs approximately 1.6606 times 10 to the negative 24th grams. This is why I was telling y'all that you have to use a T-table, because we will grow up and have longer T-tables. I know, kind of crazy. This same math works the exact same way. We're multiplying across the top and dividing by the numbers on the bottom. This will give you your answer in grams for number 3. This works the exact same way for number 4 as well. You'll set it up the same way. Instead of 4.35 times 10 to the 6, you'll have 6.022 times 10 to the 23rd and work it the exact same way. I don't like this question, number 5. It's worded very weird. So what we're going to do is we're going to remove it. Bye. I do not like the wording of that one. I liked it when I first got it, but I don't like it anymore. Number 6A, I want you to use your information that you've gathered. Define the mass number in your own words. If you Google this, I will know. So define mass number in your own words and define the atomic number. What does the atomic number tell us? What does the mass number tell us? That's what I need there. Number 7, I believe you guys can do. Number 8 is pretty fun, and that's basically what your test is going to look like. This is similar to the chart that we did earlier that looks a lot like number 9. And number 10, you can do number 10. These problems down here are pretty tough. I am going to remove them for the sake of time. So you will go through number 10, removing number 5. Let me know if you have any questions. Okay, thanks. Bye.